Hey guys, I'm gonna do a short video on Seasons4 DHU's just basic operation for some of you that have just started working at Targets or just started working on Seasons4s or DHUs. So this is a dual path unit at a Target. I'm gonna walk around this side and show you guys the basic layout and airflow of this unit. We're gonna go all the way down to this end. And you kind of get a little view of this corner coat. So guys, this unit, the airflow is going this direction and down into the store, just so you get a feel for this unit. So outdoor air intake. This unit is a dual path unit, guys. So it's got, this is one airflow. There's a deck here. This is the outside air deck. And then air here is coming up from the store and going into the unit. So there's two separate air paths. That's why this is called a dual path unit. This unit, this damper is typically 100% open all the time when the store is operating. So this unit is taking in 100% outside air through half of this system. This upper deck is 100% outside air all the time. It's a makeup air unit. So sometimes that seems a little crazy. Why are we bringing in 100 degree, 80% humidity air into a store in the summertime? That is how this unit is designed, just so you guys know. It actually does work if it's running properly. So, air in from the store, this is the lower air path, and air from outside, that's the upper air path. We go into the next door here, guys. There's a coil on the bottom, an evaporator coil or a DX cooling coil on the bottom air path for indoor air. There's a DX coil in the top. There's a set of dampers in the deck right here. Colton, if you could get up and show them that.
I think I can see it.
So when this unit is running, this actuator will turn. It'll close off this deck or bypass damper, open up these dampers, and there'll be air being drawn in from outside, being cooled and dehumidified by this coil, and then air being drawn in. It's the same blower drawing the air through the unit, guys. There's not two separate blowers here. Just trying to show you the air path here. So this is outdoor air, indoor air. This is the evaporator section. So on this unit, this is the outdoor air path. On this setup, this is compressor 1 and 1A. This is a tandem compressor. The second compressor runs off an unloader. So when the suction pressure starts getting lower and during cold weather operation, it'll only run the one compressor. It runs on a low suction pressure. It's not a low suction pressure cutout, it's an unloader. The run starts and stops the second of the tandem compressors to control capacity. You guys will notice here that there's multiple coils if you look at the way the tubes are arranged. This here, where these little U-tubes are in the front, this is a sub-cooling coil. So the liquid refrigerant comes from the condenser coil on the other end of the unit, goes through the sub-cooling coil first on the other end. I'll show you guys that in a couple minutes on the back side. So it pre-cools the liquid refrigerant, or sub-cools the liquid refrigerant, and then it comes into the TXV for this main section of the coil. This is compressor 1 and 1A. You'll notice there's a different coil back here, guys. This is for compressor 2. There's a separate compressor for pre-cooling. Again, this is outdoor air, so this is really hot, really humid air sometimes, makeup air. This is 15 tons of compressor, just this one coil here, to pre-cool the air to this coil to make this thing efficient and to dehumidify, cool this hot, wet outside air for this unit. So on the top half of this unit right here, guys, this is a 40-ton unit. There's 30 tons of cooling going on right here, just for the outside air. This is about 10 or 12 tons of cooling for the indoor air. One compressor on the bottom, 3 compressors for the top. 3 scroll compressors for the top air path, 1 scroll compressor for the bottom air path. So this is compressor 1 and 1A. As you can see by the numbers, this is compressor 2 is all it does when it gets really hot outside. This is a subcooling coil for 1 and 1A. Compressor 3 is for the indoor air path, the lower air path. The air is being drawn through the blowers right on the other side here. Again, a subcooling coil. Just subcools the liquid refrigerant before it goes into the DX cooling coil for this stage. And now if you guys look, the air is going this way. You'll see another coil here, everyone. This is a reheat coil, so similar to a humiditrol on a Lennox unit. This is a hot refrigerant gas reheat coil where they divert some of the hot gas from the compressor before it gets to the condenser coil. And we're dumping hot gas through here, trying to heat the cold air coming off of these coils. We're trying to kill the cooling effect because this is a dehumidification unit. So if it's 68 degrees in this space and we're trying to maintain 68 degrees and we've got a 50 degree supply temp, the store is going to keep getting colder. We don't want the store to get colder, is how this unit works. We want the store to keep dehumidifying. So this is there to raise the supply temp so that the store doesn't get overcooled, but that it can continue to dehumidify, running refrigeration to dehumidify, if that makes sense, everyone. This one up here also has a hot gas reheat coil, smaller than the indoor one for obvious reasons. This is warmer air, so it doesn't need to reheat as much on that stage. Hope I'm not going too fast here, guys, and I know this is a crash course, but again, hot gas reheat coil, just like a humiditrol on a Lennox or on an Aeon, if you guys have seen some of those. Hot gas reheat coil for the lower stage, and then Colton. It's got a big plug fan, or centrifugal. It's not a centrifugal, but they call it a plug fan. One big blower, guys. That's the intake of the blower on the left, is drawing the air off of both of them. These two air paths now become one air path. They both come together here. And that air goes down to the store as one air stream. But it comes in as two separate intakes, if you guys see what's going on here in this unit. Alright, so then the air goes into the blower. This is the supply air blower section. You can see this unit is a little bit different in that it has two motors. It has a low-speed fan motor and a high-speed fan motor instead of a frequency drive. That's how these units originally came out from Seasons4. So it's got some timing and relays set up to where it'll bring it up to low speed first, and then that motor will cut out, short time delay, and then it'll kick in the bigger blower motor that runs at a higher RPM. If you look to the left here, guys, you can see three separate gas-fired heat exchangers. Those are 450,000 BTUs each. This is about 1.2 or 1.3 million BTUs of gas heat. This unit will also bring on gas heat in the summertime if the hot gas reheat from the previous stage, if the temperature coming out of the blower here in the summer on a 100-degree day is still too cold and is trying to overcool the store, they will actually bring on stages of gas heat to continue to raise the discharge temperature. They're trying to get the discharge temperature to match the store temperature, the zone temp in the store, is how the programming on this unit works, guys. That bottom heat exchanger on this unit, gas-fired unit, is a modulating gas valve. So it's modulating heat on the bottom stage. Modulating gas heat on the lower main stage. Second stage, third stage is just fixed, multiple stages. This is modulating and two-stage heat, two-stage heat, two-stage heat. So there's a lot going on these units, but don't be surprised if you get up here on a hot day in the summer and you see the unit running compressors and hot gas, heat at the same time. It can happen. Not every day, but it can happen. Just so you guys know what this unit is trying to accomplish. It's a dehumidification unit, is what it's designed for. One last door, everyone. This is air going down to the store after all the stages of heat and cooling. To the left there on the wall is a humidity / temperature sensor probe. Those were added last year on a lot of these stores during the Seasons4 optimization projects. That's the ideal location for it, is at the final discharge, so that Target knows what the actual supply temperature and humidity is being supplied to the space. Here in the compressor section, everyone, this is compressor 1 and compressor 1A. These are the two compressors for the upper air path that I showed you earlier, where we're bringing in outside air. It's a tandem compressor setup, but on the wall here on the right, you can see an unloader pressure switch, and above the unloader you can see on the wall, I've written on there, this was something we did during the optimization last summer. That is where that second compressor, it unloads, so it shuts off the second compressor. When the suction pressure combined on this circuit gets below 110, it shuts off the second compressor. When the suction pressure rises to 140 psi, it brings that compressor back on again. It's capacity control, because this unit will run that outdoor air pad dehumidification if it's 60 degrees outside, because it's a dehumidification unit. It's not, you can't think about this unit as an air conditioning or heating unit. Its job is to dehumidify. So those two, 1 and 1A, if that one's marked 1, I think this is normally 1 and that's 1A. Is the outdoor air path, the primary outdoor air path. This is compressor 2. This compressor is that pre-cooling coil of the upper air path that I showed you guys before. All it does is pre-cool. This compressor pre-cools the inlet air to the evaporator coil for those two compressors and that evaporator coil on a very hot, humid day. So this one acts as a pre-cooler if it's 100 degrees and really humid outside. This compressor, this lone compressor over here, like I was showing you guys, this is the only compressor for the lower air path, for the normal air conditioning air path. Return from the store through an evaporator coil and or hot gas reheat and back to the store. One compressor does that. Those 3 compressors are just for the outside air, makeup air part of this unit. Let's come around the corner here, guys. This condenser coil section here, this condenser coil section here is for compressor 3 only. Doesn't have anything to do with 2, 1, or 1A. This one on this setup, on this unit, this is just 1 and 1A right here, condenser coil. You come over to this side of this unit. I'm sorry, on that side it's compressor 3 only. The condenser coil I showed you guys, if I misspoke there. That's compressor 3 is condenser coil over there. This is compressor 1 and 1A. You can tell it's bigger. More coil space, more tonnage of cooling. This is compressor 2 condenser coil section. So you gotta pay attention on these units. This is the inside of the beast. So all the way, you got 4 condenser fan motors. Those 4 condenser fan motors here, guys, are controlled by a Hoffman controller, pressure sensor controller. Stages those compressors on and off. There's very specific instructions for adjusting that controller. Don't mess with that unless you know what you're doing, or call somebody. This thing needs to run the way it was designed to run. But this controller has multiple temperature sensors right here tied into it that are looking at liquid temperature coming off the condenser coils, and it cycles the fans on. These 2 condenser fan relays are for this compressor, for number 3, and they are not controlled by any pressure or temperature controller. They just come on when that compressor is running. That's for the indoor air path. This one here, not controlled by the Hoffman head pressure controller. Over here, something else I wanted to show you guys. Again, these are a little bit different on the dual path units. So again, behind me right here, this is compressor 2 condenser coil. Down a little bit past me the top to bottom. The next section is compressor 1 and 1A's condenser coil section, and back behind the hidden door here, guys, is the fan motor and the back side of the condenser coil for compressor 3. You guys will notice on the wall the solenoid valves. That's the hot gas reheat solenoid valves. This unit, like a humiditrol, when it energizes and it's using hot refrigerant gas reheat, it diverts the hot refrigerant gas coming off the compressor. It uses the top half of the condenser coil. You guys can see where it's got a solenoid valve, and you see the split there. When it's running hot gas reheat, it sends half the refrigerant hot gas into this half of the condenser coil here. The other half gets diverted back to that hot gas reheat coil, where it dumps some of that heat, recovers some of that heat to raise the supply temperature of the unit so that we're not overcooling the space. But yeah, you got solenoid valves in here. Something I want to show you guys, if you look up, I'm pointing up there, you guys can see a liquid line sight glass. You cannot charge one of these units by the liquid line sight glass, guys. Never do it. Don't let it mislead you. It's there to kind of give you an idea what's going on in the system, but it is not for charging purposes. These units you want to charge by weight, and you also want to charge by superheat and subcooling. 8 to 10 degrees subcooling. But do not test these units if you think you're low on charge. You're thinking about adding refrigerant. You think it's overcharged, undercharged, trying to determine if the coils are clean or dirty. You don't want to do any of that if it's running hot gas reheat, guys, because it's diverting a bunch of hot gas. Let's say it's 100 degrees outside, and it's dumping that hot gas into basically another condenser coil that's in the cold air path. So that coil is sitting in 45 or 50 degree air. It will give you all kinds of strange low head pressure readings. You come out, reset high head pressure switches that are tripped, the thing takes off and it's running normally. When it's running hot gas reheat, as soon as it shuts off the hot gas reheat, the head pressure will jump 200 psi on one of these, guys. So what I'm trying to say is, on any of these Seasons4 units, no matter which stage it is, this one here's got the hot gas reheat bypass valves down here. You have to test run these in straight cooling only. It's the only way you can properly test run these. Verify charge, verify if the coils are dirty, is it running high head pressure. And the way you do that is in the control box. So let's say this unit's running, I get to it and its target's control is calling for reheat, and I don't want it to run reheat. I'm here and I need to put this into straight cooling. On this unit, because I've worked on this one several times, HGR's hot gas relay 1 and 3. Stage 2 does not have a hot gas reheat coil because it's the pre-cooling coil for the outside only. All you got to do is pull the relays out, guys. You pull the relay out, hot gas relay, and it can't run hot gas. That will put it into straight cooling mode, and then you can test it and know what you actually got for head pressures. So I can't say that enough, guys. I've seen that mistake made several times. You have to test this unit in straight cooling mode. You cannot test it when it's running hot gas reheat. The rest of this is a lot of controls, temperature controls, that kind of thing. I'm not going to go into all of it today, just because it becomes overwhelming. Just wanted to give you guys a rundown on the basics of how this thing runs. But what you need to know is this is a dehumidification unit. So it has a different purpose in life than a rooftop unit that's a straight cooling unit. This unit's job is to take the humidity out of the store. It cools the store at the same time as a byproduct, but it also will add some heat to that discharge air, and it will not have a 50-degree supply temp to it by design. I think that's all I've got for today, guys. Just wanted to give you a quick rundown, help some of you guys out that have never worked on them before. read the prints, read the prints, read the prints, read the prints. Take some time on these. It is a good electrical print, and you can learn a lot. It's how I learned how to work on these, is by reading the print, understanding what each circuit did, and figuring it out. They've also got a very good manual in most of these, and if you get to the middle of the manual, there's actually a sequence of operation that actually tells you a lot of the stuff I just went over, guys. So take some time, read the book, and understand it. Again, two big things on these. Don't use the sight glass to charge. The sight glass will have air in it when the unit is properly charged. And do not charge this unit or try to troubleshoot it unless it's running in straight cooling mode. That's all I got, guys. Have a good week. Be safe, everyone.